Right now, inside a highly restricted Boeing facility in St. Louis, engineers are assembling something that fundamentally reshapes how wars are fought in the air. It's called the F-47, a jet designed to vanish from radar at levels never achieved before. We're talking stealth performance estimated to be up to 50 times more effective than anything currently flying. It can penetrate over 1,000 miles deep into hostile airspace without refueling, and it doesn't fight alone. The F-47 commands a coordinated network of AI-driven drone wingmen, extending its reach, firepower, and awareness far beyond a single aircraft. China is fully aware of the program. Russia is racing to respond. And by the end of this video, you'll understand why the United States just skipped an entire generation of air combat capability. The U.S. Air Force has officially unveiled the F-47, America's first sixth-generation stealth fighter. Boeing secured the contract in March 2025, and production is already underway. The first flight is scheduled for 2028, with operational deployment targeted for 2029. But here's the key difference. This aircraft isn't an evolution of the F-22 or F-35. It's a clean sheet rethink. In practical terms, it makes both jets look like products of a different era altogether. Before we dive into the details, drop a comment and let us know, are you ready to see America's next leap in air power? Let's start with what makes the F-47 a game-changer in stealth technology. Reason 1. Stealth beyond anything ever built. The Air Force classifies the F-47 as Stealth++. To put that into perspective, the F-35 is considered stealth. The F-22 steps that up to Stealth+. The F-47 moves 2 full levels beyond that. On radar, the F-35 has a radar cross-section of roughly 0.005 square meters, about the size of a golf ball. The F-22 is even smaller, around 0.0001 square meters, roughly 50 times smaller than the F-35. The F-47 is engineered to be significantly stealthier still, with estimates suggesting a signature closer to the size of a small marble on radar. But radar is only part of the equation. The F-47 is designed with all-aspect, broadband, low observability. That means it's built to evade not just traditional radar, but infrared sensors tracking engine heat, passive electronic systems listening for emissions, and modern sensor fusion networks designed to detect patterns rather than single signals. Its engines dramatically suppress thermal output. Its communications operate at ultra-low probability of intercept, making data sharing nearly invisible to enemy systems. This isn't just about dodging missiles. It's about operating freely inside heavily defended airspace, where every sensor is active, every frequency is monitored, and detection usually means destruction, yet remaining unseen the entire time. The F-47 can push deep into hostile airspace, strike high-value targets, and leave without the enemy ever realizing it was there. That's not just superiority, that's true air dominance. Reason 2. A combat radius that rewrites strategy. The F-47 has an officially stated combat radius of over 1,000 nautical miles, roughly 1,150 statute miles, representing about a 25% increase over current U.S. fighters. In regions like the Pacific, where vast ocean distances separate friendly bases from contested zones, this changes everything. Today's fighters rely heavily on aerial refueling to reach deep targets. The problem is, those tankers are among the most vulnerable assets in the air. They're large, slow, and easily tracked. Once tankers are threatened, entire air operations start to collapse. The F-47 breaks that dependency. It launches from bases well outside enemy missile range. Refueling aircraft remain even farther back, beyond the reach of long-range threats. Meanwhile, the F-47 penetrates contested zones, completes its mission, and returns without ever entering the engagement envelope of ground-based defenses. And that 1,000+ figure is intentionally imprecise. The real range is classified and could extend 50 to 250 nautical miles beyond what's been publicly stated. The Air Force is keeping that number vague for a reason. Uncertainty forces adversaries to plan for the worst without knowing the jet's true limits. China has spent decades constructing layered air defenses and deploying long-range missiles specifically to hold U.S. bases at risk. The F-47's range effectively neutralizes that strategy. American forces can operate from secure locations while still delivering decisive power exactly where it's needed.
Before we move on, take 1 second to hit like and subscribe. Nearly 98% of viewers watching right now aren't subscribed. It's free and it directly helps the channel grow. 1 click makes a real difference. Thank you. Reason 3. An entire drone force under one pilot's control. The F-47 was never meant to fight alone. From the start, it was engineered to command AI-driven drone wingmen known as collaborative combat aircraft. Each F-47 is designed to control 2 to 5 advanced drones at the same time. In recent testing, a single fighter successfully managed 8 drones simultaneously, and the F-47's more advanced systems suggest that number could grow even further. When an F-47 enters combat, it doesn't represent a single aircraft. It arrives as a coordinated formation. These drones have a combat radius of roughly 700 nautical miles and can be tasked with multiple roles, carrying weapons, scouting ahead, jamming enemy communications, or deliberately drawing fire to shield the manned fighter. This completely reshapes the math of air combat. What looks like 1 jet on radar can instantly become 6, 8, or even 10 synchronized platforms operating together with machine speed coordination and shared situational awareness. The artificial intelligence behind these drones allows them to execute complex maneuvers, react to threats, and adapt to changing battlefield conditions without constant pilot micromanagement. And just as important, the drones are dramatically cheaper than manned fighters. If one is lost, it's a tactical setback, not the loss of a highly trained pilot or a $300 million aircraft. That cost imbalance enables aggressive tactics that would be unacceptable with traditional jets. In this system, the pilot isn't just flying, they're commanding a distributed force. With 185 F-47s planned, the Air Force could field 1,000 to 1,500 combat-capable platforms when drone wingmen are included. That scale of coordinated air power has never existed before. Reason 4. Revolutionary engine technology. The F-47 is powered by next-generation adaptive cycle turbofan engines, representing a true engineering breakthrough. For decades, fighter engines faced a hard trade-off: optimize for fuel efficiency or optimize for high-speed performance. You could lean toward one, but never fully have both. Every fighter in history has lived with that compromise. The F-47's engines eliminate it. They dynamically adjust their bypass ratio in flight. When efficiency matters, long-range cruising across vast distances, the engine configures itself for minimal fuel burn. When combat demands maximum thrust, it instantly shifts to high-power mode. The pilot doesn't touch a switch. The system adapts automatically in real time. This isn't just about going faster or farther. It's about having the ideal engine configuration at every moment. The jet can cruise efficiently across the Pacific, then transition to full combat power the instant threats appear.
These engines also generate significantly more electrical power while managing heat far more effectively. That energy feeds stronger radar systems detecting targets at greater ranges, advanced sensors tracking multiple threats simultaneously, and electronic warfare suites capable of jamming communications and disrupting enemy targeting. Control of the electromagnetic spectrum is now a core part of air combat, and the F-47 is built to dominate it. The engines also enable supercruise, sustained supersonic flight without afterburners. Afterburners consume enormous amounts of fuel and produce massive infrared signatures. Supercruise avoids both. The F-47 can maintain speeds above Mach 2, stay fuel efficient, and preserve its low thermal visibility at the same time. Reason 5. Designed specifically for Pacific dominance. Every major design decision behind the F-47 reflects one priority: winning a high-end conflict in the Pacific against peer adversaries. China has invested heavily in anti-access strategies meant to keep U.S. forces at a distance. That includes deploying hundreds of ballistic missiles capable of striking air bases in Japan, South Korea, and Guam. The logic is simple: disable those bases, and American air power can't operate. The F-47 renders that strategy ineffective. Its extended range allows operations from bases well beyond missile reach. Even Guam becomes less relevant as medium-range missile systems struggle to threaten the more distant locations the F-47 can exploit. Once airborne, its extreme stealth allows it to penetrate the dense air defense networks China has built over decades: surface-to-air missiles, radar arrays, and fighter patrols, none of which matter if they never detect the aircraft. The F-47 can slip through layered defenses, eliminate high-value targets, and exit before the enemy even realizes an attack occurred. The Air Force has been clear about its purpose. The F-47 is designed to achieve air superiority in the most heavily contested environments on Earth, the exact conditions where advanced defenses are actively hunting U.S. aircraft. There's a broader strategic message here. By fielding the F-47, the United States signals that decades of investment in anti-access and area denial systems won't stop American air power. No matter how many missiles or defenses are deployed, the ability to project force remains intact. That deterrent effect alone is immensely valuable. Reason 6. Complete information dominance. Modern air combat is no longer decided by speed or maneuverability alone. It's decided by information. Whoever sees first, understands first, and acts first usually wins. The F-47 is built to dominate that information battlespace in a way no previous fighter could. At its core is advanced sensor fusion, merging inputs from dozens of onboard systems: radar, infrared sensors, electronic warfare receivers, and communications into a single, unified operational picture. Instead of managing separate feeds, the pilot sees one clear, coherent view of the entire battlespace. But the F-47 doesn't stop there. It continuously integrates data from other F-47s, AI drone wingmen, satellites, ground-based radar, naval vessels, and wider command networks, creating a real-time, shared understanding across the force. Imagine this scenario. An F-47 deep inside contested airspace detects a weak radar return. A drone wingman registers an infrared anomaly nearby. A satellite identifies electronic emissions in the same region. Another F-47, operating 100 miles away, receives a brief contact. Instantly, the F-47's fusion systems correlate them, identifying a hostile aircraft, calculating its trajectory, classifying the threat, and presenting engagement options, all in real time.
This capability extends well beyond targeting. The F-47 identifies threats before they become dangerous. Electronic warfare systems detect enemy radar searches the moment they begin. The aircraft can maneuver to avoid detection or jam the radar before a lock is achieved. Communications intercepts reveal enemy intent automatically, without pilot intervention. The result is a pilot who always knows where threats are, what they're doing, and what they're likely to do next, often before the enemy even realizes the F-47 is present. That's true information superiority. Reason 7. Far higher combat availability. The F-47 isn't just designed to win fights, it's designed to be available to fight them. Current stealth fighters struggle here. The F-22 often requires around 50 hours of maintenance for every flight hour, driven by delicate stealth coatings, complex subsystems, specialized equipment, and highly trained personnel. When something fails, repairs can take weeks, leaving large portions of the fleet grounded at any given time. The F-35 faces similar challenges. Maintenance and sustainment issues have consistently limited availability rates. In a crisis, expensive aircraft stuck in hangars instead of flying missions become a serious operational weakness. The F-47 is deliberately engineered to break that cycle. The Air Force has stated clearly that it will achieve higher availability than both the F-22 and F-35, with more aircraft mission-ready at any moment. It accomplishes this through modular design. Faulty components are removed and replaced quickly, without lengthy diagnostics or teardown. Technicians swap modules, and the aircraft returns to service in hours rather than days. Stealth materials and coatings are also more durable and easier to maintain, reflecting hard lessons learned from earlier programs. The F-47 requires less specialized ground equipment and infrastructure. Unlike previous stealth fighters that demanded climate-controlled hangars and extensive support systems, the F-47 can operate from more austere bases with minimal infrastructure. In a prolonged conflict, this matters enormously. The side that keeps more aircraft flying more often with less downtime gains a decisive advantage. By design, the F-47 doesn't just win the air battle, it wins the logistics and sustainment battle as well. Reason 8. A smart investment in air power. At first glance, the F-47's $300 million price tag per jet, roughly 3 times the cost of an F-35, might seem staggering, but that perspective misses the bigger picture. The F-47 isn't just a single fighter, it's a complete combat ecosystem. Each aircraft commands multiple drone wingmen, multiplying its operational impact. In effect, buying one F-47 gives you a formation of 6 to 8 coordinated platforms, not just a lone jet. Do the math. 185 F-47s at $300 million each totals $55.5 billion. That's expensive, but it includes potentially 1,000 to 1,500 drones, nearly 2,000 platforms in total. Divide the total cost by all of these assets, and the per-aircraft cost drops dramatically. The F-47 is built on an open architecture, allowing systems to be upgraded incrementally as new technology emerges, without expensive redesigns or years-long retrofit programs. Older fighters relied on proprietary closed systems. Adding new capabilities often meant returning the aircraft to the manufacturer, paying huge sums and waiting years. With the F-47, new sensors, weapons, electronic warfare systems, and AI upgrades can be integrated quickly and affordably. That keeps it at the cutting edge throughout its service life. The Air Force also confirmed that operating costs will be lower than the F-22, which translates to more training hours, more aircraft ready for missions, and a higher number of combat sorties on the same budget. When you consider force multiplication from drones, upgrade potential, and lower operating costs, the F-47 represents an extremely smart, long-term investment in American air superiority.